Hey guys, welcome to Section 5, Chapter 11 of the Algebra 1 program, and this is your final video for the program. So congratulations, you've made it all the way to the end. You're just about done, and this is our last section of new material before we review for your final course assessment. So congrats, it's super exciting. All right, we're going to take everything that we've learned about radicals and we are going to apply them to radical equations now. So the only thing that we need to be careful of that we've never encountered before is something called extraneous solutions. And what that means is that sometimes algebraically you come up with one or two answers or sometimes more. And the math seems to end up right, but when you check the solution in the problem, it doesn't work. So this is sometimes a loophole we get caught in with radicals because both positive and negative numbers can be applied when taking square roots and things like that. So it's just something we're going to watch, and it means that we have to check every answer that we get. Okay, so without further ado, let's jump in. What if we have the square root of x plus 3 equals 11? So I'm going to subtract 3 from both sides, and I'm going to get square root of x equals 8. And now, in order to undo that square root, I'm going to square both sides. So the beautiful thing about algebra is you can do a lot to the equations as long as you do it to both sides. And when you square a square root, you get simply what's underneath that square root. So I'm going to get x, and then 8 squared is 64. Now, like I just said about extraneous solutions, what I need to do is check this answer. So I wonder if the square root of 64 plus 3 equals 11. Well, the square root of 64 is 8 plus 3 equals 11, and it works. So x equals 64 is my answer to this problem. All right, not too bad. Let's do another one. What if I have the square root of x plus 6 equals 2? Well, when the entire side is underneath the radical, then I can start by simply squaring both sides because I can't do anything until I get rid of that radical. And again, what we're left with when we square a square root is simply what's underneath the radical. And then 2 squared is 4. Solving for x, I'm going to subtract 6 from both sides, and I'm going to get x equals 2. Now, before I circle it, I'm going to plug it in. Is negative 2 plus 6 underneath the square root the same as 2? That's the question. Negative 2 plus 6 is 4, and 2 equals 2. So yes, that is going to work. All right, let's work on a case that maybe it's not going to work out so well for us. What if I have negative 6 minus square root of 3y equals negative 3? All right, I've got to get the term with the square root all by itself. So I'm going to add 6 to both sides, and I'm going to get negative square root of 3y equals 3. Now I have this negative out front. There's two ways to deal with it. Probably the easiest way for you is to multiply both sides by negative 1. So I'm going to get a positive square root of 3y equals negative 3. And I'm going to do that because then when you square it, it's going to be easier to see. And again, when I square a square root, I get simply what's underneath there. Now negative 3 squared is 9, and y equals 3. Okay, so now we need to go back in and check it. So negative 6, we'll just do right check here, minus the square root of 3 times 3 equals negative 3. That's the question. So negative 6 minus the square root of 9 equals negative 3. Well, the square root of 9 is 3, but now I get negative 9 equals negative 3. That's impossible. So even though mathematically we arrived at this number, the answer is no solution. And that's why we have to check our work when we're dealing with radicals. Okay, let's do another one. What if I have the square root of 3x minus 5 equals 4? Okay, I want to get the term with the radical all by itself. So I'm going to add 5 to both sides and get 9. Now I'm going to square both sides. When I square a square root, I simply get what's underneath. 9 squared is going to be 81, and x is going to be 27. Now I'm going to check. The square root of 3 times 27 minus 5 equals 4, question mark. So this is the square root of 81 minus 5 equals 4, and 9 minus 5 equals 4, which of course 4 equals 4. So yeah, this guy works. We're good to go. Okay, what if we have a equals the square root of 7a minus 6? All right, I have a square root term all by itself, so I'm free to go ahead and square both sides. Don't freak out on me. That simply means that on the left side, we're going to get a squared. And then we're going to get 7a minus 6, just what's underneath that radical. Now I got to get everybody to the same size because I am looking at a quadratic here. And now we should be very proficient at being able to solve quadratics. Remember, we take the factors of the first term and factors of the last term that are going to add to negative 7. So in this case, it's going to be negative 6 and negative 1 are going to equal 0. And then I set them both equal to 0, and I get a equals 6 and a equals 1. And now I have to check both of those numbers to make sure I don't have extraneous solutions. So let's start with 6. So 6 equals the square root of 7 times 6 minus 6. So that's going to be 42 minus 6, which is the square root of 36. Okay, so that works. And then let's try 1. 1 equals the square root of 7 times 1 minus 6. 1 equals 7 minus 6. 1 equals the square root of 1, and 1 equals 1. So in this case, actually, both answers work. Very often they don't. One will work and the other won't. So that's why it's really important that we check. Okay? All right, hang with me. I got 2 more for you. All right, what if we have the square root of 6x minus 4 equals the square root of 4x plus 6? All right, everything is under the radical, so the first thing I have to do is square both sides. And I'm going to get 6x minus 4 equals 4x plus 6. I'm going to get the x's together on the left side, so I'm going to subtract 4x from both sides and get 2x. Then I'm going to add 4 to both sides here for my constant, and x is going to equal 5. Now let's see if that's true. 6 times 5 minus 4, is that going to be equal to 4 times 5 plus 6? So this is 30 minus 4, which is the square root of 26. This is 20 plus 6, which is also the square root of 26. So that works. All right, let's do one more for you, and you're going to be good to go here. What if I have the square root of 5x minus 7, and that's going to equal the square root of 6x plus 11? All right, same scenario as before, where I've got everything underneath the radical, so the very first thing I have to do is square both sides. All right, now I'm going to get my x's on the right side, because that's going to keep them positive. I'm going to get x over here. Then I'm going to subtract 11 and get negative 18. So x equals negative 18. Right away, you should be concerned a little bit. Anyone know why? Because I think maybe there's a chance we're going to get a negative underneath the radical. And that's going to be a problem. So if we have 5 times negative 18 minus 7, and then 6 times negative 18 plus 11, guess what? Negatives underneath the radical. And that means actually we have no solution. All right, that's why it's really important to check your answers and to reason your answers and to remember things like we can't have negatives underneath the radical. Okay, you guys, that's it. You did it. Last assignment here. Go ahead and finish up your notes, read through the examples, and begin your assignment.